So in this question here, I'm going to integrate log of z plus 4 with regards to z over this contour gamma. Now, when we're talking about contours and we've got z's, we're into complex analysis. So z is a complex number of the form x plus iy. I is our imaginary constant, and x and y determine our real part and the value of our imaginary part. Now, gamma is a rectangle with boundary plus or minus 3 for x, and y is plus or minus 2. And as these points are included, as it's not a less than or a greater than, then we know it's a closed contour. So to help us to get there, we can use Cauchy's integral formula. Now, before we progress, we need to have a look at this integrand. So f of z equals log of z plus 4. Now, in complex analysis, log takes a slightly different form than it does in real analysis. So the log of a function z, that is determined as the natural log of the modulus of z plus I times the argument of z. Now, notice here I've got capital L and capital A. So this is what's termed as the principal value, as there would be an infinite solutions to the argument of z for any number on the complex plane. So log of z takes that form. So here we've got log of z plus 4. So let's draw all our information on the complex plane and see what we get. So that'd be our real, that's our imaginary, and let's draw our gamma, which is a rectangle of boundary x plus or minus 3, y plus or minus 2. So that's our minus 3, that's our plus 3, that's our 2, that's our minus 2. So our contour there, which is a closed contour, so it's including up to the edges of this as well. So here x is plus 3, and that would also count as being within our closed contour. So then we need to look at our log of z plus 4. Now, where is this defined and where it's not defined? So the log of z plus 4, this would have a branch cut from minus 4 on the real axis going in the direction of negative infinity. So there'd be, if I just go along here a bit more, just be a little branch cut to eliminate that from our domain. So now we've got this information, let's have a go at sorting out our integral. So we've got the closed contour gamma and log of z plus 4 dz. So now we want to work out where this function here, f of z, is analytic. Now, if you look at everywhere inside that closed contour, now, interestingly for log, for this function, 0 is still analytic. If it's just log of z, 0 would be undefined. So it would be non-analytic at that part. So as this function is analytic everywhere inside that closed contour and the boundary, then the result of this logarithm is 0. And it doesn't matter if this was positively traversed or negatively traversed, going in either direction, all the way around, the result would still be the same. We would still get 0. And that's by the Cauchy Goursat theorem. So Cauchy Goursat theorem. And that's a nice, easy way of getting to a result for a complex logarithm in terms of log, tan, cos, sine, all kinds of functions. So you can get the result without actually doing any integration, and it's a great little trick for complex analysis. Okay,